So we're going to go over graphing quadratics, and we're going to start off with our standard form. Now, we're starting off with the hardest thing that we have, not because I want to torture you, but because this is going to be our basic form of every single quadratic that we're ever going to do. The other forms have a lot more information, but it goes through a process and it takes some time. We will talk about how to get to that later, but for now, we're just going to graph them. So our goals for today are to be able to understand how to graph a quadratic function. We also want to understand what the standard form or the general form of a quadratic actually is and what it does and means. So our standard form is our most bare bones basic form of a quadratic. It's called general form as well. I prefer that term because standard form, especially like in the UK, means that it's been written, like it is a number written as a scientific notation, so it can get confusing. General form of a quadratic is a lot more, like it makes more sense to more people. And this form is f of x is equal to ax squared plus bx plus c. Now, as a note here, let me do it in this color. A, b, and c, these are all just numbers. They're just here to help us understand what's going on. And every single parabola, every single quadratic is based off of our one general parent function. Our one general parent function is when we only have x squared. So we have y is equal to x squared. It'd be the same thing as saying f of x is equal to 1x squared plus 0x plus 0. And every single function that we're going to do is, or every single quadratic, every single parabola is going to be based off of this shape. And if you're to plug it all in, you'd eventually end up with something that looks like this. And if you go back to our dance moves, that's the kind of shape that we're looking for. So every single parabola is going to be based off of this. Every single other form that we're going to use is going to be based off of standard form as well. So this is really important to be able to understand and know what's going on. Just know that we can graph an equation in this form. It is really ugly and it looks really scary and it will take a little bit of work, but we can do it. So let's talk about how to do it. And the way how is we're given this equation, f of x is equal to ax squared plus bx plus c. And so with this equation, f of x is equal to ax squared plus bx plus c, we're going to find the axis of symmetry because every parabola is symmetric. That means that we can draw a line straight down the middle of it, and everything to the right of that line will be mirrored onto the left side of it. So that means that we can exploit this and cheat and only do half of the work. If we plug in a number on one side, we know that the y value that it spits out is going to be the same on the other side as long as they're the same distance away. And the way that we find our axis of symmetry is through a beautiful little equation. And remember that since it's a line, it's a vertical line, it has to have x being equal to something. And our equation is going to be negative b over 2a, or in the other words, opposite of b over 2a. We will eventually talk about how to get here and what it means, and it's through a thing called the quadratic formula. But for now, just like memorize this and understand that it comes from. And b just means the number in front of x. A just means the number in front of x squared. We're not going to include x squared or x in this. We're just going to include the number in front. And what we're going to do after we have found our axis of symmetry is we're going to use that to find our vertex and build a table around the axis. Because we can cheat. If we only have to do half of the points, then we're only going to do half of the points. So let's do it that way and like cheat and save ourselves some time. C is our y-intercept up here. It's really helpful sometimes. If it's going to be somewhere on the graph that you're graphing, it's great. If it's something like negative 1,000 and your graph only goes to, say, negative 10, it's not going to be helpful at all. But it can be. So remember that C is our y-intercept, because if you're to plug in 0 for x, you would get 0 plus C. That's the only thing that's left. It's the only thing that'll spit out. Now our vertex magically appears in this flash of like fireworks and everything. Our vertex is actually on the line of symmetry. The way that we can find it is if we plug in this number here, right here. I'll box it just for you. If we plug in that number into our function, it'll spit out something for y. That y value is going to be the y value of our axis of symmetry and of our vertex, and our vertex is going to be negative b over 2a for our x value, and then f of negative b over 2a. It looks really scary this way. Just remember that you find the axis of symmetry and plug it into your function, and that'll give you your answer. So let's graph something. Here is a graphing example. We have f of x is equal to negative x squared minus 4x minus 2. Remember that our basic bare bones function is ax squared plus bx plus c. You notice here that these are all pluses. These are all positives. So if you ever see a negative out in front, that means that the negative is actually attached to the number. So in this case, a is a negative number. And you're thinking, well, there is no number in front of that. But there is. Our number in front of that is going to be 1, because 1 is always just chilling out in front of our variables in front of anything, because 1 times anything is going to be that anything out. So our answer, so here our a is actually negative 1, our b is negative 4, and our c is negative 2. Let's go ahead and build ourselves our axis of symmetry. So we're going to find our axis of symmetry. And remember that we find it by plugging it in, all these numbers, into this equation. X is equal to the opposite of b over 2a. So what is b? Well, b is negative 4. What is the opposite of negative 4? So x is equal to negative 4. What is 2? Well, 2 is still 2, and a, in this case, is going to be negative 1. So we have 4, because these become positive, 4 over negative 2, which is going to give us out a negative 2. That means that our axis of symmetry is this line, x is equal to negative 2. That means everything is going to be flipped about that, and our parabola is going to have a vertex, or it's going to start somewhere on x is equal to negative 2. Now, here's how we're going to find out where it actually starts. We're going to plug in negative 2 for x. So everywhere that there is an x within this function, we are going to plug in negative 2. So we have f of what? Well, f of negative 2. And what is that equal to? That's a negative, because we have a negative 1 in front of that. So we have a negative what? Well, it's a negative x squared. So we plug in negative 2 for our x, and we're going to square that. And we're going to subtract from that 4 times what? Well, we're timesing it by x. X in this case is now negative 2. And then we're going to subtract from that 2, because there's nothing left. The c doesn't have a 2 attached to it. Now let's plug these out into our head, into a calculator or something. Negative 2 squared is going to be 4. It's going to be a positive 4, because you have a negative times a negative, and that's a positive. But now we have a 4 times a negative out here, this negative right there. So we're actually going to get out negative 4. And then we're going to subtract 4 times negative 2. Well, 4 times negative 2 is negative 8, but we're subtracting negative 8 from that, so we're actually adding it. And then we're going to subtract 2 from that. Now we have negative 4 plus 8, which is negative 4. Or sorry, negative 4 plus 8 is positive 4. Then we're going to subtract 2 from that, and we're going to get out 2. So our vertex here is at negative 2, 2. We're going to do that for every other point. Now, I have already plugged these into a calculator, so I already know what's going to be the answer here. I'm going to point out the fact that we have a x or a y-intercept negative 2, and so that's when x is equal to 0. Well, that's going to be really easy, because negative 2 is on our graph. So we're going to put that there. And let's plug in the number 1. So we plug in the number 1 for x. We plug it in, chug it all out. What we're going to get out is a positive 1. So at x is equal to negative 1. That's a negative right there. And when x is equal to negative 1, we're going to spit out a 1. Now, remember, we can flip it. So these points all have matching points on the other side. So this one here, which is 1 away from our vertex on the x direction, is going to be 1 away from our vertex here. It's going to be right there. And then this one over here, which is 2 away from our vertex, is going to, our axis of symmetry is going to be 2 away from our axis of symmetry on this other side. And now at this point, we're just going to draw our graph. And we're going to connect our dots. You notice it has the same kind of basic shape as the equation y is equal to x squared. It's just been moved around and shifted upside down, and it looks a little bit different, but it's the same thing. And that's how you graph it. Let's do it again. We're going to find our axis of symmetry. And remember that our axis of symmetry is x is equal to the opposite of b over 2 times a. So in this case, when we plug in everything, we're going to get negative 8 over 2 times negative 2. We plug it in, we chug it out, what we're going to get as our axis of symmetry is negative 2. Now, when we plug in negative 2 into our function, we're going to get f of negative 2. Let me make that a little bit more clear. F of negative 2 is equal to negative 2 times negative 2 squared minus 8 times negative 2. That's a 2. Minus 3, because remember we're plugging in negative 2 everywhere that there's an x. And when you plug it in and chug it all out, what you're going to get out is a 5. So at our axis of symmetry, here, let's draw that in real quick. At negative 2, we're going to go up to 5. And when you plug in some other numbers, let's do negative 1 and 0. At 0, we're going to be at negative 3 because of this intercept. So we're going to be down here at negative 3. At negative 1, if you plug it in and chug it out, you're going to be at 3. And then remember that we can flip it across. The other way that we can think of it is if we did negative 3. Here, let me do it in a different color so it's obvious. Negative 3, negative 4. So we went down by 1, down by 1. Whereas here we went up by 1, up 1 by 1. When we went up by 1, we got spit out a 3. So when we went down by 1, it's going to spit out a 3. When we went down by 2, we spit out negative 3. Going up by 2, we're going to spit out a negative 3. Positive 3, negative 3. Yeah, negative 3, negative 3. And then we draw in those points as we need to. That was a little bit off. There we go. And draw a graph. And that's it. That's all that you have to do when you're graphing these equations. So now I want you to do a quick check, and I want you to graph each of these equations. They're all in standard form, even number 2, which looks really scary, but remember it's actually plus 0x plus 0. That's the same way where if you add 0 to it, you're not doing anything, but it helps us understand what's going on. So go ahead and graph each of these equations and check them in Desmos. I want you to graph and then check because that'll help you understand what's going on. Don't check and then graph. That's kind of cheating. So go ahead, pause the video, do this quick check, and once you're done with this quick check, you are done with the lesson.